We have generalized the concept of differentiation to functions with two or more independent variables. How can we do the same with integration, and how can we interpret the results? Let's look first at the operation of anti-differentiation. We can anti-differentiate a function of two or more variables with respect to one of the variables by treating all the other variables as though they were constant. I mean, for example, integral 6xy squared plus 3x squared dx equals, now we integrate in terms of the x, so we consider y as a independent constant. Okay, so integral of the 6x, so integral of the x is x squared over 2, so this is 3x squared y squared plus integral of the x squared is x cube over 3, so this is x cube. On the other hand, if we have some terms here which is depends on the y, derivative of this terms is also 0. I mean, for example, derivative of this function can be easily calculated, and which is 6x times y squared plus 3x squared. So if we have here, for example, y squared plus 1 or sine y, or y cube times sine y plus 4y squared plus blah blah blah, some function of the y. Okay, in this case we have y squared plus 1, that's right. We can say that this is 0. Okay, so this derivative is 0 in terms of the x. So here we can add the some function of the y. So integral of this function is that function. For example, 3x squared y squared plus x cube plus sine y, or 3x squared times y squared plus x cube plus y cube sine y plus 4y squared. But this have to be function of the x. It cannot be included the x term, function of the y. Okay. On the other hand, we can talk about the integral of the same function with respect to y dy. So this is 6xy cube over 3. So 2xy cube. And the integral of the 3x squared is considered as a constant, so 3x squared y. Now, derivative of this term is the integrand, okay? But if we have a derivative of this term with respect to y is the integral, okay? The integrand, this one. So here the constant term can be a function of the x. So here we can add the constant term c of x. For example, 3xy cube plus 2xy cube plus 3x squared y x squared plus sine x plus 4, for example, is the answer, one of the answers. So the result of the definite integral with respect to x or y is a function of the x and y. Okay. Thus, this operation is the reverse operation of the partial differentiation, just as ordinary anti-differentiation is the reverse operation of the ordinary differentiation. We will write integral f of xy dx to indicate that we are the antiderivative f of xy with respect to x. Okay, I mean the integral f of xy dx indicate that to the antiderivative of f of xy. Okay, so antiderivative of f of xy, of course with respect to x. with respect to x. And similarly, f of xy dy is the antiderivative of f of xy with respect to y. So how we calculate? By fixing the x and y and x respectively. You can calculate this antiderivatives or these integrals as a definite case. Okay, easily you can calculate. For example, from 0 to 2, 6xy square plus 3x square dx equals the differences of the this function. Okay, so c of y is not important because you will c of y terms will be cancelled. Okay, so this is 3x square y square plus x cube and x change from 0 to 2. So the answer is a function of the y. Okay, so you will find 3 times 2 square y square plus 2 square minus, for x equals 0, this is 0. So 12y square plus 4 is the answer. Or similarly, you can calculate this one, 6ay square plus 3x square dy easily can be calculated. Sometimes, as you see, the result is function of the y. Sometimes we consider these two integral together. Okay, I mean from 0 to 2, from 0 to 2, or let's change one of them. Let's say this is from 0 to 1. In our textbook it is different. 6xy square plus 3x square. First we integrate in terms of the y, let's say dy, let's write here 1. Okay, and we integrate this obtained function. It's a function of x. You can calculate. Okay, let's calculate above. What is the integral of the 6xy square? 2xy cube plus 3x square y. So y changed from 0 to 1. Here x changed from 0 to 2 in the first case. So this equals 2x plus 3x square. For y equals 0, this is 0. So the answer here, we differentiate first in terms of the x. So this one is this value. So integral from 0 to 2, 2x plus 3x square dx. So this is x square plus x cube. X change from 0 to 2. So the answer 2 square plus 2 cube. So 8 plus 4, 12. Okay. And also it is possible to calculate this integral in the inverse order from 0 to 1 dy and from 0 to 2 6xy square plus 3x square dx. Okay, if you calculate in this way, you will see the very surprising result. Actually, it's not surprising for the mathematicians, but for it may surprising. So this is already calculated, which is 12y square plus 4 dy. This is 12y cube over 3, so 4y cube plus 4y. Y change from 0 to 1. So this is 4 plus 4. Minus 0. This is 8. But where is the mistake? Let's check our calculation. Okay, I found our mistake. So for x equals to, this is x to power 3. So this should be 8 to the power 3. To the power 3. So this is 8. Okay. So this term is 8. So this is 8y. This is 8. So this result is 12. So this is not the chance to be same. So these values always are the same values. Okay, so in this order or in that order. The order is not important, but the limit of the integrand are very important. Actually, in this section, we will generalize this integral to the double integral. By generalizing by generalizing this given integral to double integral, we can define the following way. Okay, this is definition. The double integral of a function f of xy over a rectangular region. Let's define our rectangular region as the following way, which is consists of the x and y such that x between a and b and y between c and d. So what is this region? Easily you can observe this region. This is x-axis, this is y-axis. So x change between a and b, y change between c and d. So intersection of this one. So this is our rectangular region. So on this region, the double integral denoted by the double integral sign on the region R. What is the R? R is this region. Okay, R f of xy for any function dA. We denote by the dA instead of the dx or dy, dx times dy or dy times dx, but here dA may be dx times dy or dy times dx. In the rectangular region, this order is not important, but you will see in the another region, general region, the order will be very important. When describing your region, you will decide this order. So here we can say that this integral equals from a to b. A and b are change of the x, so we integrate dx at the end of the calculation. So first we integrate in terms of the y from c to d, f of xy dy. Okay, so the order is important here actually. So c y change from c to d, so this is dy. Okay, and x change from a to b, so this is dx. Okay, so this is change of the x, this is change of the y. Or you can use the following one, which equals from c to d. So we integrate in terms of the y at the end of the calculation. First we calculate from a to b, f of xy dx. Okay, so here x change from a to b and y change from c to d. Okay, so these orders are important. Okay, inside integral and outside integral important. So in the inside integral we integrate in terms of the y in the first one, so y change from c to d. In the outside integral we integrate in terms of x, so x change from a to b. Also from here you can observe. This is the definition of the double integral. So as you see, if you have a rectangular region, easily you can calculate your double integral. You can use what you know about the definite integral or indefinite integral, does not matter. You can use when solving this type of the question. Let's look to the easy example. Easy example. Our aim to calculate this integral 2x e to power x square plus y dA on the region R. In the both region, okay, you can calculate over, or R is the region. It consists of the x and y such that x change between 0 and 1, y change between -1 and 1. So it's not necessary, but let's show that our region x change between 0 and 1, y change between -1 and 1. So our region is this region. This point is 1. So this integral, let's note by the I, the integral equals integral from, in the any order you can write, okay? In your textbook, I'm looking at your textbook, dx dy order is used. So let's use dy dx order. So y change from, first we should write the x change, okay? So x change from 0 to 1 dx, and y change from -1 to 1, 2 times x e to power x squared plus y. Okay, so first of all, we should calculate this integral, then we will evaluate the other one. So from 0 to 1. 2x should be considered as a constant because in terms of the y we integrate. So 2x. Integral of the e to power x squared plus y, x squared is considered as a constant, e to power x squared plus y, times or over derivative of this function with respect to y, which is 1. Okay, so we don't need that one. So this is the integral of this function in terms of the y. If you want, you can evaluate derivative of this function in terms of the y is that one. So y change from -1 to 1 and dx. So for y equals 1, 2x e to power x squared plus 1. For y equals -1, minus 2x e to power x squared minus 1 dx. So now we should calculate these differences. Or the integral of these differences. So here, if you say x squared plus 1 is u or x squared minus 1 is v, we need the two different substitution. Actually, we have two integral, 2x e to power x squared plus 1 dx, minus from 0 to 1, 2x e to power x squared minus 1 dx, okay? So for the first case, let's say x squared plus 1 is u. So this implies 2x dx is du. So the first integral will be, I will write the limit of the integrand later. 2x dx will be du, so e to power u du. And when x equals 0, u is 1. When x equals 1, u is 2. So from 1 to 2. Minus, let's look the second one. Let x squared minus 1 equals v. So this implies 2x dx is dv. So the second integral is integral e to power v dv. What is the v? For x equals 0, v is -1. For x equals 1, v is 0. Okay. So we should calculate this integral. Integral of the e to power u is e to power u. So u change from 1 to 2. Minus e to power v integral is e to power v. V change from -1 to 0. So e square minus e to power 1 minus e to power 0 minus e to power -1 is our answer, okay? You can say that e square minus e minus 1 plus 1 over e is the answer, okay? By the inverse order, also you can calculate. I mean, if you want, you can calculate this double integral as in the following order: dA from -1 to 1, from 0 to 1, 2x e to power x squared plus y, dx dy. In this order also you can calculate. You will find the same answer. This solution can be found in your textbook. Okay. So by this way we complete the double integral for rectangular region. It is very easy. In addition to this fact, we can talk about the average of the two variable function. Okay, so the average of the two variable function, this is another definition. The average value over rectangular region. So this equals on the interval r, of course. So the average value of f of xy over r consists of the x and y given rectangular region. X change between a and b, y change between c and d. Okay, so the average value equals integral give us the summation. So we should divide the area of this region. So what is the area of this region? B minus A times D minus C. Okay. So times double integral f of xy dA on the region A. Actually here our region is from A to B, from C to D. So this is our rectangular region. So area of this rectangular region is, this length is B minus A, this length is D minus C. So B minus A times D minus C. So by using this formula, you can calculate the average value of the two variable function on the rectangular region. In addition to average value, we have another application of the double integral. So by using double integral, we can calculate the volume of some solid. I mean, for example, this is the graph of the function f of xy, or surface. Okay, actually this is graph, but this is describe the surface. So here we have a rectangular region. This is A, this is B, this is C, this is D. This is our rectangular region. So on this rectangular region, we have some solid. Symbolically I show that. Okay. So the volume of this solid. Okay, the volume of this solid the volume equals double integral on the region R f of xy dA is the volume of this region, which is very similar to the area. For the area, what is that one? Recall please. We have a graph of some function f of x equals y. So x change from A to B. So this area is the integral from A to B f of x dx. So here we have a two variable function. So the double integral of the two variable function give us the volume of the solid. Okay, on like this one.